Akid Hafriz bin Muhammad. I will explain to you about the features in Smart Solar House Power Management System. Okay. In this house, we implemented 3 systems, which is limiting system, reminder system, and power saving mode. Okay. For power limiting system, the system is to ensure that the user not use exceed 5,000 watt of the power usage, total power usage in one time. Okay. The total power usage exceed 5,000 watt, the appliance will not working. Okay, let me show you some example. Which if I switch on the first appliance, the total power usage now is 1,500 watt. I switch on the second appliance, the power usage is now 3,500 watt, and for the third appliance, the total power usage is now 4,500 watt. And if I switch on the fourth appliance, the system is not working because the power usage just now is 4,500 watt, which if this appliance working, the total power usage will exceed 5,000. Therefore, to switch on the fourth appliance, we have to switch off any other appliance, which is optional to the user, which appliance they want to switch off. Okay, let's say they switch off the second appliance, so the total power usage will drop and the fourth appliance will be allowed to be working. Okay. Next is the reminder system. Reminder system is to aware the user about the current power usage. Okay, we have implement 3 stage of this reminder system. First is 50% of the power usage, which is about 2,500 watt. Okay, so when the power usage reach this stage, the buzzer will beep once. Okay, if the power usage is reached about 75%, the buzzer will beep twice. And the final stage which 90% of power usage, 4,500 watt, the buzzer will beep 3 times. Okay. Third one is the battery saving mode. To optimize the battery usage in the house, we had create a system which called saving mode. So as the battery reach 30%, the battery will trigger the saving mode, where the saving mode will optimize the usage of the battery. Okay, it only allow the continuous and basic need of the appliance. For example, refrigerator, lighting system, and cooling system. Okay. So as the battery reach 30%, any other appliance are not allowed except for basic needs like what I just told before. Okay, I think that's all for me. Thank you.
My name is Suhaila Binti Saulaiman. So I will explain what is the purpose methodology used in power scheduling system for our smart solar house. We will use MATLAB and Simulink, and then for the current stage, we have tested both of the coding for optimal scheduling with renewable energy use and the optimal scheduling without renewable energy use. As you can see from here, there is no difference between the two, with and without. So this is our issue now. We will, for the suggested plan, we will try to modify and analyze the coding so that we will get the answer. Actually, this is not the main system that we will use. This is just we want to use it to compare the with and without, to show the user that the significance of the smart solar house. And this is the upgraded work we do for this week. We have find all the brands of the appliances, and for the future works, we will create a simple coding, and then we will interface it by using Arduino, and the Arduino could control all the features in the house based on the power system that had been created. So now I am going to present to you the comfort control mechanism, which is the air quality monitoring system. So currently we are building the software coding, and we are doing the integration between software and hardware, and we have find an example of schematic diagram to be followed, and also we have purchased all the materials and components that is needed to design this project. So this is the proposed methodology hardware. We use MQ135 sensor as the air quality sensor, Arduino Uno as the software, the LEDs, buzzer and fans as the output hardware. So this is the main feature of MQ135. So as you can see here, this sensor is very sensitive to harmful gas and gases such as ammonia, sulfur and benzene. The DC supply is 5 volt only, and it is portable and suitable for domestic applications. It also needs only simple dry circuit and long life and have low cost. So this is the schematic diagram for air quality monitoring system, which is we have Wi-Fi module, buzzer, LCD, and the MQ135. So this is the actual Arduino connection with MQ135. So the control mechanism of air quality monitoring system is the input, which is the air quality, will be measured by the MQ135 based on different type of gases, and then the data will be sent to the Arduino software to be processed, and then the Arduino will execute instructions to the output hardware, and then the output hardware, which is first one is buzzer, will emit a sound to alert the user, and LED will emit a bright light to indicate the level of pollutant. The higher the concentration of pollutant will cause the LED will light brighter, and then the fans will turn on to get rid the polluted area, and the result will allow a good ventilation of air. So this is our future works. We will finish building the coding, and the second one is we will add more sensors such as ozone sensor and dust sensor, and the third one is we will implement Wi-Fi module, which is will be interfaced with user smartphone, so that they can monitor their smart home air quality.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahrul Amri bin Mustapa. I will explain about comfort condition lighting. Okay, this is the schematic diagram. This is surrounding light, and then LDR, and then Arduino, relay and LED bulb. This schematic diagram is for AC LED bulb. It uses 240 volt. That's why we need to use relay. But for the prototype, we do not use the relay and LED bulb for AC because its light is too strong and not suitable for simulation. We just use DC LED. Okay, for this is the daylight factor, EI over EO multiplied with 100. EI is indoor illuminance and EO is outdoor illuminance. Okay, for the house diagram, we use 3 LED for each room, and each room has LDR and PIR motion sensor. And the outside also has 4 LDR because we want to calculate the daylight factor. We take the mean outside LDR reading over each inside LDR reading, multiply with 100 to get the daylight factor, and if daylight factor is less than 4%, more LED will light up. Okay, this I have prepared the first prototype. If light is bright, the LED is turned off. If light is quite dark, LED is turned on. Okay, that's all from me. Thank you.